grade 11 learners? Welcome back to our class Earth Science grade 11. Once again, this is your teacher, Mom and Magdadaro. So why don't we join me today as we're going to learn more about our topics or lessons in week 4. So we are going to tackle lessons 7 and 8. In lesson 7, we are going to tackle about the structure and the evolution of the ocean basins. While in lesson 8, we are going to study about the different plate boundaries. So join me today as we're going to learn more about these topics.
Milk 7. Describe the structure and evolution of the ocean basins. The following objectives are: number 1, enumerate the different structures of the ocean basins and describe each. Number 2, to describe the evolution of the ocean basins. So last week we discussed about the stresses in rocks and the seafloor spreading. So let's review our past discussion by answering the following questions. Let's review by finding out the hidden word from the given phrases below. Let us start with the first phrase. Let's go, yo! What do you think is the hidden word? The correct answer is geyo. The pronunciation of this word is not guyot but geyo. The third one. Oh, Sean gave out his trendy clothes to the different churches. What do you think is the hidden word? The correct answer is ocean trenches. So we have the O, the Shan, the Tren, and the Ches. So ocean trenches. Number 4. She considers having a tea at 9 in her natal day with her sloppy pet. What do you think is the hidden word? The correct answer is yes, it's continental slope. And the last number. I see the beautiful mountains from where I am standing. What do you think is the word? With the given picture, what do you think is the structure that is hidden from that sentence? And the correct answer is the sea mounts. Now, based from our previous discussion, which is also the introduction of our lesson today, we are talking about the different structures of the ocean basins. So, based from the picture, you see that the seafloor is comprised of these different parts. So, we have here abyssal plain, next the mid-oceanic ridge, then we have the geo, and we have the trench, the seamount, and we have the continental shelf, the continental slope, and the continental rise, and of course some transform fault. So how are oceans generated? The Earth is about 4.5 billion years old, but oceans are 3.8 billion years old. There are two main theories describing how oceans are formed. The first one, it says that the Earth was formed with water and that this water comes from the inside out. And next, the Earth was a dry planet with water brought here by some other sources. Now, talking about the formation of the ocean goes from 3 phases. The first phase is what we call the initial water vapor in the atmosphere, which the air in the ground surface was too hot for the liquid. And the second one was the cooling of the atmosphere led to condensation and rain, which is the ground surface still too hot for the pooling. And the third one is the further cooling of ground surface finally led to the accumulation of liquid water on surface. And then it goes to the formation of the ocean for about 3.8 billion years ago. Now, when we talked about the evolution of the oceans, 180 million years ago, the continents were united in a single supercontinent called Pangaea. And these oceans were like a single body which covered the whole land called Panthalassa. So due to the plate tectonic theory, it moved to their present position now, which is subdivided into the different plates or the 7 continental plates. So now there are 5 major oceans that are present in the world. So, Tethys Ocean was an ocean that existed between the continents of Gondwana and Laurasia. Due to the plate tectonics movement, the Tethys Ocean disappeared. So, in our present time, we have already the different divisions of the planet, which is the Pacific Ocean, Atlantic Ocean, the Indian Ocean, the Arctic Ocean, and the Antarctic Ocean. So let us talk about the different stages in the formation of the ocean basins. First off, we have the embryonic stage. So just like its name, embryonic is the first stage of ocean basin evolution. In this stage, the rift valley is formed while the continent begins to split. However, before the ocean basin experienced the rifting and also the volcanic at the beginning, the movement that appears in this stage is the uplifting of the bottom part of the ocean. And this kind of movement allows the formation of the rift valley and the splitting of the continent. Now, on the other hand, there are some examples for the embryonic stage, such as the Great Rift Valley, the Southern Red Sea, and the Eastern Africa. In this very first stage, you can see a complex system that is marked by the linear rift valley and/or the continents. After the embryonic stage, we have the juvenile stage. So in this stage, the movement that appears and happens is the subsidence of the ocean bottom, and it will spread. Now the subsidence and the spreading will create a deviation of the continent, and because of this diverge, the seafloor basalt will be created. So basically, when the separation happens, the gap is filled with the basalt, and that is how the basalt is created. So meanwhile, juvenile stage makes the existence of oceanic crust occur below the sea level with the shape of the thin and dense. An example of the juvenile stage is the Red Sea, and also in this stage, you can see that the narrow seas will match the coast perfectly. Next up, after the juvenile stage of ocean basin evolution, we have the mature stage. For the mature stage, the ocean basin experienced the widening, trench developing, and the start of subduction. An example for the mature stage is the Atlantic Ocean. Then, to know either the stage of the ocean basin evolution is in mature stage or not, there is the characteristic that you can know. The characteristic is the existence of the continental margins in the ocean seafloor that creates the ocean basins. In the declining stage, the movement that appears and happens is the continuous of the subduction. And because of this, the ocean seafloor and also the ocean ridge is being eliminated. There is one example of the declining stage, which is the Pacific Ocean. So to know either the ocean basin is in the declining stage or not, there is a character that differentiates this stage from another stages. And in addition, usually the geologists will see either there is an island arc and an island trenches around the basin edge or not. So if there is, the ocean basin is in the stage of declining. And the terminal stage, the ocean basin that has been created is shallow. So meanwhile, to let you know which ocean is in the terminal stage or not, you can see the existence of the young mountains in the ocean. If the ocean or the seas are narrow, irregular, and exist the young mountains there, it means that the oceans and or the less is in the terminal stage. An example of the sea that is in the terminal stage is the Mediterranean Sea. Another example of the terminal stage is the Persian Gulf. And now we have continental collision as the last stage of the ocean basin evolution. Many people also know the continental collision stage as the southern stage. In this stage, the movement that appears and happens kind of the same with the mature stage, which are the uplift and the convergence. Then, what makes it different from the mature stage is that in the continental collision, the young mountain will grow and become the mature mountains. The changes from the young mountains become mature mountains is being caused by the colliding of the continents. So after the elimination of the seafloor and the colliding of the continents, there will be creation or the formation of the continental mountains chain. The examples of the continental collision are the Himalaya and Tibetan Plateau. So moving to our next lesson, which is lesson 8, the plate boundaries. This is focusing on MELC 8.1, which is to explain how the movement of plate leads to the formation of faults, and trenches. After going through this lesson, you will meet with the following objectives. A. To define and describe what plate tectonic theory is all about. B. Differentiate the different types of boundaries and their effects. Don't you know that all the 7 continents of the Earth were once joined together like pieces of jigsaw puzzle? Alfred Wegener was a German scientist who formed the theory of plate tectonics and proposed the idea of the continental drift theory. This theory states that the Earth is broken into several plates that are constantly moving and drifting, resulting in some changes of the Earth. After some time, the dramatic changes that we see in the Earth crust, like the mountain ranges, new islands, or earthquakes, occur along the plate boundaries. There are 3 types of plate boundaries: divergent plate boundary, convergent plate boundary, and the transform plate boundary. Convergent boundary occurs when the 2 plates collide. There are 3 types of this. First is the continental to continental. This occurs when the 2 plates of continental crust collide. They buckle and thicken and cause mountains to form. Next is continental to ocean collision. When the 2 plates of ocean crust collide with the plate of continental crust, the ocean crust, which is more thicker, subducts or goes underneath the continental crust. The magma from the melted oceanic crust rises to the surface and results to volcanoes along the boundaries. The third is the ocean-to-ocean collision that occurs when 2 plates of oceanic crust collide. The older dense plate subducts under the younger plate, and as a result, the crust melts and creates a volcanic arc or island arc. Next up is the divergent boundary. This is when 2 plates moved away from each other. The separation allows the asthenosphere to rise to the surface and partially melts. And this melting occurs magma and which erupts as lava. And this lava cools down and creates new rock and ocean floor on new continental crust. Most of the divergent boundary are located in the ocean floor. However, rift valleys may also form when the continents separated by plates. Finally, transform boundaries, which is the 3rd type of plate boundaries, occur where 2 plates slide past each other. When the plates move next to each other, they do not go along smoothly. They scrape each other, and these can be felt as earthquake. Unlike the other boundaries, transform boundaries do not produce magma. The San Andreas Fault in California is an example of transform boundary. So there we go. We have the 3 types of plate boundaries: the convergent, divergent, and the transform boundaries.
And this is your teacher leaving you this beautiful quote of the day: that an investment of knowledge is the greatest interest. So I hope that you'll invest more on your learning. So I'll see you all in our next learning episode.